So, this is a interesting one, interesting slide, so to say, where I have compared the soft computing with hard computing. When I am telling soft computing, it also indirectly hints to another one, which is hard computing. If there is no hard computing, then the soft computing word would not have come. So, in case of the hard computing, which is generally the computer system is having, which is binary, you are having mathematical world, it is hard data, raw data, it is quantitative, it is not qualitative, it has bivalent reasoning, yes or no, there is no in between, just like we are doing in the fuzzy system. On the other hand, the soft computing one has linguistic world, it has soft data, interpretation is possible, whatever you are doing you can interpret to the other party, understanding is there, explanation is there, why I am doing, you can explain, it is qualitative, it may be bivalent, may be multivalent. Okay. Now, these are some of the advantage of soft computing. I think we need to go for a tea break, is it? No? Fine. Okay, fine. Now, the advantage of soft computing, I have mostly already covered this portion. Models based on human reasoning, which I was giving the examples. It can be linguistic, it is simple, comprehensible, fast when it is computing, and it may be good in practice. If you go for a practicing scene, it may be good, it may not be, I should not say that everywhere it will be good, but it may be a good scenario, okay, if it is properly designed. Now, coming to the evolutionary computation, which I have already discussed a little bit, it is a complex optimization problem and it has lot of application in any optimization field where we want to find out the optimized values. Even a simple example, how many are from electrical background here? Nobody. Then electronics. MCA. MCA backgrounds are there. Okay. Then I will little bit twist my talk. Management people are okay. So, see, anywhere you go for some parameters to be found out, then suppose a management system is there or a industry is there and I want to find out that which parameter I should tune so that I will get maximum profit. Parameter may be human resource, maybe raw material, maybe something I am unable to actually get into it because my area is a little bit different. So, suppose 3 parameters are there and the problem is what should be these parameters for this year so that I will get maximum profit, right. So, that can be handled with the help of genetic algorithm. Even now many people are using neural network for your share forecasting. In fact, we have used many, you can see there are 2 or 3 papers of mine where I have used neural network for electrical load forecasting. What will be my electrical load after 2 days? If I can say, then my production industry, that is NTPC, NHPC, whomsoever it may be, they will be ready for that. If suddenly from 50 megawatt it is going to 100 megawatt, I cannot produce. I need coal for that. It has to come somewhere. It is to be processed. It takes time. So, I must predict what will be the scenario next 2 days. Like that, if I can predict what will be the share of the TCS today, Today if I can predict for tomorrow or day after tomorrow, I can purchase. So that can be done with the help of neural network. And in neural network, you can use this optimization algorithm as well. Okay. So this is not required. So let us come to the mathematics little bit. I should not go into always giving lectures. I should come into the mathematics little bit. When I am optimizing a function is there which is having variables x1, x2 up to xn. N number of variables are there, and I want to optimize this function. Means I want to find out the values of x1 to xn such that my function should be having minimum or maximum value, either of the two. Now this maximization or minimization or optimization can be of two types. One is unconstrained optimization and another is constrained optimization. Unconstrained is there is no restriction on the values of x1 up to x. These are some of the limits where x should be within -2 to 5. So many limits can be put on the system which are called constrained optimization. Okay. Now you see this is a function which has having two minimum. One is here and one is here. My problem is, what is this? This is -4, this is 4. Within -4 to 4, find out the minimum value of x such that my y is minimum. Find out the value of x such that my y is minimum. Then I should get this value. It is -3.5 or something. I should not get this value. I should get this value. Then only it is a global optimization. Otherwise, it is local optimization. Okay. These are some of the optimization techniques where it is basically Newton's method, the generally one which we use, that is your differential one, and in the evolutionary one, it is genetic algorithm, bacteria foraging, simulated learning, dynamic programming, all these are coming into picture. Okay. Tea break? No problem.
We should have a photo session outside. There will be a break from 10 minutes.
अभी कर देंगे ना?
कोई आप सब डिस्कस
नहीं, ये तो चलता रहेगा ये थोड़ी.
एक्शन सर कर दीजिए.
Now, as I was discussing that the gradient method and the GA and PSO, BFA, everything are having in its own aim, and the aim is to get to a optimized value. This is a program that I have written in MATLAB using a gradient function, right? And you see this is a function having one maxima here, one local maxima here, and there is one local maxima here. Now, since this function is an analytical function, I can find out the gradient, that is differentiation. But in practice, you cannot find the differentiation value explicitly. It must come numerically. Okay. So, whenever I am going for a gradient calculation, using some numerical algorithm, I define a initial condition, and from that initial condition it starts. So, here I have started a initial condition 5 and I am using the gradient. So, when I am running it, see, it is gradually going towards where? To the local maximum. It will be trapped. This is one by one run I am giving, iteration basically, and it is being trapped to the local maximum. See, as it is going towards maxima, the variation is very slow, and now it has reached the maxima, so there is no more change even if I am running it. Okay. Now I will change my initial condition. I have changed it to 3. Okay. Now you see, it is going towards, that is global maximum. So, the gradient method can also find the global maxima and minima if it is properly started. If the initial condition is proper, you can achieve the thing. However, since we do not know where is the global one, I cannot start my initial condition also. If I know it beforehand, then I can start easily. But since I do not know, I cannot start my global point as well. Therefore, we go for the evolutionary computation. And that is particularly the program that I have written, each for GA. See, this is a GA based program where I am starting with 40 random populations and there are 3 maxima. This one is the global maximum. So, when I will run it, generation 1, see 1, 2, third generation I have gone. What is happening? All the points which was initially 40 has converged to the single point, and that is the global point. So, this is the beauty of the evolutionary computation. I am not telling about GA only, but this can be achieved through any other. But the value that I am getting here, if this is a very that means simple system, I can easily achieve this point even by binary method G. But that cannot be achieved if it is a complex one. And when the parameters that are optimizing or that you want to optimize are correlated very much with each other. You know correlation? Suppose A, B, C, 3 parameters are there and A and B are very much correlated, then you cannot change A and B independently. If you are changing A and B independently, then you will get some result, but that will be a suboptimal. Okay. So, these are 2 examples that I have shown through MATLAB, and now I am skipping this genetic algorithm portion because this will be dealt and you also know already. So, I should not take much time on this. You know mutation and crossover? What is mutation? No, what is the physical interpretation of mutation?
Malpractice.
Huh?
Malpractice.
Malpractice. Exactly what do you mean? Yes, that may be. I don't correlate. But what do you mean by that?
So to play a little bit trying to get the desired result.
But why it comes to the mind to put a mutation? Okay, crossover. Crossover is used for producing new children, right? Now crossover is generally done in the LSB side or MSB side. Why? Your answer is perfect. It is done in the LSB side.
When you are making some changes on LSB, effect will be less. Will change
You need less effect or more effect?
And bits are parent.
Because from the parents to children, the behavior does not change much. Should not change much. It may be 20%, 30% maximum. It should not change by 200%. Right? Similarly, what about mutation?
What about Raman?
Hmm?
Raman.
Ravan, what happened?
उसके father son थे और वो राक्षस तो completely change हो गया 30%.
यही तो आएगा म्यूटेशन में. यही मैं म्यूटेशन को ही बोलने वाला था. रावण जब पहले जन्म हुआ था, when he was born, he was not Ravan. He may be something और बहुत पूजा करता था, शिव पूजा करता था, बट बाद में रावण बना है. That is called mutation. Suppose there are, now you all are engineers. Can you just say that you will not be a murderer next day? Can be. Who knows? कुछ हो गया तुम्हारे ऊपर. That is, something has happened on yourself. It is nothing to come from the heredity. वो क्या है? वो मैं ज़्यादा जानता नहीं हूँ ना. आप अगर वो बताएंगे तो हम सोचेंगे फिर. नहीं, see, and actually these are the facts which if you analyze you can produce a new algorithm. And nowadays also new algorithms are coming. ये जो बैक्टीरिया फोरेजिंग जो मैं बोलने वाला हूँ, ये कहाँ से आया? यही से तो आया है. Recently just I want to refer, I should not refer that one. I was reviewing one paper that is called Bard flocking algorithm. Bard जो जाते हैं ना, they are moving together. शाम को देखेंगे all are moving together not. So that is some swarming behavior is there. कुछ सिग्नलिंग हो रहा है कि जिसमें वो एक बार में जाके फटाक से पहुंच जाते हैं उनका गोल. So what is the mathematics inside that? You represent that mathematics. You will get one paper and that will be widely referred. You cannot believe this bacteria foraging paper has, I was just yesterday looking, it has 150 citation now. 150. And I have published in 2005. 150 citation is a very high number. Citation you mean? You understand na? Means suppose you are publishing one IEEE paper. I am publishing one IEEE paper. Both of them are going for an interview. Both of us are having IEEE. So who is better than us? Another one. You have to decide. There comes the citation. If I am having 20 IEEE and you are having 2 IEEE, तो gone case. वो तो हो गया, that I will be selected, provided that 2 IEEE should not have faced Nobel Prize. Okay. So there comes the citation, and there are many sites where you get citation. Even Google Scholar can give you the citation. Simplest one is Google Scholar, but we are purchasing different, that means softwares, using giving many around 7 lakhs, 8 lakhs rupees per time. Okay, so those things what you are telling that Ravan, then other one is what? Prahlad. So those things you think why that has happened, and try to do some mathematics, then you will see that some other things has reached. Out of Rakshas, you have got a god, so to say. So from a non-optimized solution, you are getting a very good optimized solution. So how it is possible? How it has been done? Okay, and mutation is nothing but that one. Changing this character of the same person. It is not by any swapping from two chromosomes. It is the same chromosome or same population is changing. Already you born ho gaya and now his character is changing. हाँ. Okay. So now I will come to my algorithm that is called bacteria foraging algorithm. This is also a parallel processing algorithm analogous to genetic algorithm, where we try to mimic the behavior of E. coli bacteria present in our intestine. So in our intestine we are having E. coli bacteria whose function is what? To destroy our body, right? If the concentration increases, you will go for dysentery, you have to take antibiotic, etc. Otherwise you will not be alive in the world. So these E. coli bacteria which are present in our intestine always float in our intestinal fluid. So they swim through their flagellum. This is called as flagella. Okay, these are all medical terms, maybe I don't know. Okay, so they swim in the fluid. If the flagella is concentrated like this, then it will swim in a particular direction. If they are flattened, then it moves in random direction, and that random direction they don't know where it will be. So that random direction will be decided by our bloody fluid. What is the velocity of the fluid will decide how they will move. But they will just make like this and again they will squeeze. So they will move in a certain direction and again they will try to swim in the particular direction. So this is the two behavior. These are the two behavior they undergo. One is swimming and another is tumbling. This random movement is called as tumble. So with swimming and tumbling, a E. coli bacteria moves in our intestine. Right? Now, there are maybe 20 or 30 E. coli bacteria. Suppose let us assume very simple number of population, small number of population. Now, from among these 20 bacteria, one bacteria may be successful. When I am telling successful, what do you mean? It is getting more food. What is the aim of that E. coli bacteria? Our aim is doing some mathematical optimization and all. But what is the aim of that E. coli bacteria? To eat more and more. That is his aim, nothing else. Okay? So he will try to heat on the food which is there inside our body. And that food may be a good quality food or may be a poisonous food. Agar antibiotic le liye ho and if that fellow is taking that one, then he will die. So it may be poisonous or it may be good. So whenever he is going to the poisonous one, he will come out of that. He will try to come out. Whether he will be able to not come out or not, it is different. But he will try to go out of that. But if he is getting good concentration of food, then he will move in that direction. Right? But here there is a catch. If that E. coli bacteria will move in the particular direction for a long time, it may be tracked to a local concentration of food. Food is there everywhere, but somewhere the food may be 1 milligram, somewhere it may be 100 milligram. It is getting 1 milligram food is there, yes, I should go, but it may be trapped to 1 milligram, which is nothing but local milligram. So that E. coli bacteria, what it will do? It will not move for a longer period in a particular direction. It will not try to exhaust all amount of food there. But after some time, it will again make a tumble and go away in different direction. Just like our fishes do inside the river. Right. So, after particular amount of swimming, they will go for again a tumbling. And this total set of swimming and tumbling combining together is called as chemotactic stage. Chemotactic stage of a E. coli bacteria. So, inside a chemotactic stage, how many procedures they do have? One is swimming, another is tumbling. Now, if he is getting good amount of food, good quality of food, then he will swim for some time, then tumble. But at the beginning, if he is getting not good quality of food, that is poisonous or notorious food, then from the beginning he will tumble and he will try to go in a different direction. So, these two sets comprises your chemotactic.